During World War II, Germany deployed a great amount of effort and resources for the development of a super heavy tank. In the spring of 1942, Ferdinand Porsche considered the possibility of a tank armed with a 150mm cannon installed in a fully rotating turret alongside a 20mm coaxial cannon. This prototype, which is depicted in the illustration, was called Mammoth, and it was the earliest conception of the Maus. The largest part of tank designers and theorists opposed the employment of super heavy tanks, but in that time Ferdinand Porsche was at the head of the German Tank Commission, and thus he had a considerable influence with Hitler, who urged the development of such tanks. The Alcott Company began to assemble the first Mammoth tank the August 1, 1943, and in mid-September Krupp provided the hull. The new tank, known by then as Maus, undertook its first trial the December 23, 1943, in Alcott. The January 10, 1944, the tank was sent to undertake extensive tests in Bollingen, near Stuttgart. Apart from small problems with the suspension, the tests had a remarkable success. Therefore, Hitler gave to Porsche the order to have the new tank ready in June of that year. The June 9th, the turret was installed onto the hull and subsequently additional tests were carried out. The tests were satisfactory, and in the beginning of October, the tank was sent to the Kummersdorf test fields. Since the Maus weighed 188 tons, it required exceptionally wide tracks of roughly 1 meter in width, which were almost as wide as the space between them. Being a mechanical monstrosity, the Maus was anything but environmentally friendly. It cracked the surface of the roads on its wake and produced disturbing fuel emissions and noise, besides vibrations which threatened with shattering nearby window panes. The first prototype of the Maus was propelled by a 1,000 horsepower Mercedes-Benz MB 509 gasoline engine, which had been originally conceived for aircraft. Theoretically, this 12-cylinder inline engine should have allowed the Maus to reach a top speed of 20 km/h in road, but in practice the speed rarely exceeded 13 km/h. The second prototype was fitted with a 1,200 horsepower Daimler-Benz MB 517 diesel engine. The cutaway illustration which will be presented hereafter corresponds to this second prototype. The L/55kW 128mm cannon was back then the largest anti-tank cannon ever installed in a vehicle, and it had the potential of destroying any contemporary tank in service. The provision of ammunition for this cannon comprised 32 rounds, most of which were carried on the hull's sideward protrusions known as sponsons. The formerly 20mm coaxial cannon was replaced by an L/36.5 kWk 75mm cannon. This new coaxial cannon exasperated the restrictions of internal space in the turret and ammunition storage, as a larger breech and 100 rounds had to be accommodated. Many contemporary tanks had cannons of this caliber as their main armament, and they did not carry as many rounds. As in other German heavy tanks, the armor was made from rolled steel plates and the unions were interlocked, fastened with pins and welded. The glassy armor plate had 240 mm in thickness and a considerable slope to maximize the relative thickness and the chances of ricocheting projectiles under the most common impact angles. The seats on the driving compartment were reclined to accommodate their facing to this slope. The driving compartment was isolated from the rest of the tank and was accessed through a hatch on the hull's roof. The driver was accompanied by the communications operator. To increase its structural resistance, the glassy armor plate located in front of them did not have any opening. The driver had to rely on a simple episcope to view the exterior without exposing his head. Steering and changes of speed were effectuated through levers and pedals. On each side of the hull, the Maus had a total of 12 pairs of support wheels assembled on 6 bogies, interleaved in such a way that there were 4 rolling lines along the track's width. Above each bogie, there were 2 return rollers interleaved in a similar way. The bogies were attached to very robust beams, crossing the hull from side to side. On each bogie, the 4 wheels were held by 2 crank arms and 2 coil springs, which served as their suspension system. The ruin of the Maus was its weight. Anywhere the Maus transited it left a footprint. The tracks damaged the pavement of the roads and caused vibrations capable of cracking nearby window panes. Due to its excessive weight, the Maus sank in any terrain which had a minimal amount of humidity, despite rolling on tracks which had 110 centimeters in width. Besides, for covering a distance of 180 kilometers, the Maus required 4,200 liters of fuel, something that Germany was not in position to afford. The internal fuel tanks were located one at each side of the driving compartment, and they contained about 1,325 liters of fuel each, an amount which should be enough for traveling about 150 kilometers on road and 60 kilometers off-road. The internal combustion engine and its cooling system occupied the space right after the driving compartment, and there was a large grating located right above them to dissipate the heat. A protective bulkhead separated the driving compartment from the engine compartment except for a small hatch to perform maintenance. The original gasoline engine was replaced by an MB 517 1200 horsepower diesel engine with 12 cylinders in V. There were air intakes and an exhaust duct at each side of this hull section. The engine's crankshaft was attached to a large electric generator, which in turn supplied power to the 2 electric motors, which were the actual propulsion system of the Maus. The whole system, which includes the internal combustion engine, the electric generator and the 2 electric motors, is known as electric transmission. Ferdinand Porsche had adopted this propulsion system for the Elephant tank destroyer before undertaking the development of the Maus. The turret was fitted with shock-absorbing elements to protect the crew from the horizontal component of the energy delivered by impacts from large-caliber projectiles. The turret could be rotated by means of a crankwheel mechanism if the hydraulic mechanism was not operative. This task could require considerable effort because the turret weighed 50 tons. Besides, a lot of turns would be necessary to complete the 360-degree arc. The crankwheel actuated on a mechanism which delivered the force applied to a large pinion, which in turn actuated on a rack carved on the inner face of the turret's ring. The large drum attached to the rear of the Maus was a supplemental fuel tank containing about 1,500 liters of fuel, which would add about 80 kilometers to the quite restricted operational range. The electric motors were designed to move the Maus at a top speed of 20 km/h when working at 3,100 revolutions per minute. They moved the drive sprockets through simple reduction gear mechanisms, which could be shifted for either road or cross-country operation. The propulsion system known as electric transmission has been successful in propelling submarines and locomotives, but it demonstrated to be unsuitable for propelling tanks, because these vehicles have to overcome a greater mechanical resistance due to their tracks, and they have a more restricted space for accommodating their propulsion system. The Maus could be waterproofed to cross a river whose bed were at a maximum depth of 12 meters. The idea of using trunks for sending air to the engine and letting the gases to escape did not give a satisfactory result because the flow was excessively limited. It was then decided to take advantage of the electric motors for this purpose. Since the Maus lacked batteries which could supply energy to the electric motors, a second tank stationed in the riverbank would have to supply it through a cable. Once the first tank had crossed the river, the roles would be reversed to allow the second tank to cross the river.